In this lecture, I am going to explain the first question of our mathematical logic few problems we collected. In that, this is the first problem. Let P and Q be primitive statements for which the implication P implies Q is false. So, in the problem, they already said P implies Q is false. Determine the truth values for each of the following, like that 4 bits they gave. P implies Q is false, they mentioned. Before this statement is important, for that you write the truth table for PQ. Possibilities we know, right? Both are true, one is true, one is false. One is false, one is true, and both are false, right? Then truth false is there means false, and in other cases it will be true. In the last lecture we already discussed about the truth tables, and whenever you are using the formula, habituate to write in the margin. You will remember that, okay? TF is false because they mentioned clear. P implies Q is false. Means from this statement you need to find out what is P and what is Q. So it is understood P is T and Q is false, right? So P is equal to true and Q is equal to false. Now they are asking that P intersection Q. Intersection element means it must be P must be true, Q must be true, then it will be true. In remaining all cases, it will be false, right? So, the answer of this is false. You can write that here. P intersection Q. If both are true, then only it is true. In other cases, it is false. So the different one, if you are writing, you will remember. In other cases, it is false. Other cases means we know, right? Both are true. One is true, one is false, one is false, one is true, both false. So except this, remaining all cases, it is false. That's what first bit answer I got false. And next one, see, negation P union Q is there. See, again, P is equal to 2, true, and Q is equal to false, right? This we have to use it. Negation P. Negation P is nothing but just reverse. P is true, negation P is false. Now, negation P union Q. What is the status of union? See here, P union Q is nothing but if both are false, then the result is false. In other cases, it is true. Both are false, it is false. Otherwise, it is true. In other cases, it is true. See here, what is the status of this? Negation P is false and Q also false. So, both are false only, na? So, the result is false. The second bit is over. Now, coming to this third bit, Q implies P, they asked. Again, we will write Q implies P, right? Write the Q first. What is the Q? Here you can see this one. Q is false and P is equal to true. Then Q implies P, and already we have the truth table here. If TF only F, remaining cases it is true. Here see, FT is there, so it will be true. And fourth bit, negation Q implies negation P. Again I will write P value is P truth value. It is true and Q is equal to false, right? So negation Q I will write first because negation Q implies negation P, they asked na, due to that reason. Negation Q opposite to false is true. And again negation P opposite to true is false. Now I'll write negation Q implies negation P. See here, true, false. See, status true, false. Result is false only, na? Right. This is the solution of the problem. Depend on the truth table, this type of questions there is a chance to ask. Thank you.